what is cos, and so on of cos x. Hello everyone, today we will solve a limit which is as limit n goes infinity of cos and so on of cos x, where cos is taken n times and it goes infinity. Firstly, I would suggest you to try it yourself because only way to learn mathematics is to do mathematics. Okay, so let's see the solution. Let us assume this limit as L. Let us assume this limit as L. Now what if we take cos both sides? Cos of limit n goes infinity cos of cos and so on of cos x equals to cos L. Now what is this here? Now I would like to deviate you from this problem itself to understand you that what will come after this step. Okay, so let us assume a limit a as limit n goes 3 of cos x. So now we have assumed a different limit a in which n goes 3 and cos x. I can rewrite a as cos 3 times cos x. Okay, this is a symbolic representation of this expression. Now what if I take cos both sides? After taking cos both sides here, it will be cos x. It will be cos of limit n goes 3 of cos these two things are similar if we remove that 3 by infinity. Now we can rewrite this as limit n goes 3 of so now I can rewrite this expression as this limit n goes 3 of cos x, where cos is n plus 1 times. So when n goes 3, it will be 4 times. So cos will be 4 times here. So these two expressions are same itself. It was n times. So now we can observe an interesting thing here, that cos of this limit equals to limit of this cos, and now number of times cos will be increased by 1. So now my whole discussion says that we can write this whole thing as limit of n goes infinity of cos x, where cos is taken n plus 1 times. We can see the similarities here and here. Only 3 is replaced by infinity. So I mean to say that we can take this cos inside and write that these cos are n plus 1 times, because I have take this extra cos, so there will be n plus 1 times here. So now this equals to that, and cos L will be itself in this side. Now we can write n goes infinity as n plus 1 goes infinity. Now we can again make an observation then that these two limits are itself same. How I can say that is that number of coses goes infinity here too, and also in here number of cos goes infinity. So if you would take a depth look, you would find that these two limits are same itself, because in both cases we are taking cos infinite times. Okay, so if you understand, then I can write this as that and that as L. So L equals to cos of L. Really satisfying, because we have converted a monstrous looking limit as a trigonometric equation. There are many ways to continue from here, but I would like to discuss the easiest way. If you know the expansion formula of cos x, then you can write this as 1 minus L square over 2 plus L to the 4 over 24 minus dot dot dot. So now we are aiming to solve this system, but it would be even more tough because there are infinite terms here. So but here's the catch, because we have to find this limit which we have already assumed as L. So now we have to find the L from here. What if we take a look at the range of L? We know that cos L belongs -1 to 1, because cos L equals to L, so L will also share the same range. Now we have observed that L will be definitely between -1 to 1. So what if I take the cos L again? So cos L belong, if L lies between -1 to 1, the least value of cos L will be cos 1. Okay, the least value of cos L will be cos 1 if L lies between -1 to 1. And the largest value will be 1 when L equals to 0. Because this is a range, so there will be -1 and there will be minus half, then there will be -1, minus half, 0, half and 1. So between this range, maximum value of cos will be when L is 0. I hope that you get that the range of cos L belongs cos 1 to 1. Now we know that cos pi by 3 is less than cos 1. And we know what is cos pi by 3 is. Pi by 3 is half. So cos 1 is greater than half. Okay, so cos 1 is greater than half. So I can write here that cos L is greater than half. Cos L is greater than half, and cos L is less than even equals to 1. So now we can observe that cos L will lie between 1 and half. Because L equals to cos L, from here I can say that L is greater than half and less than equals to 1. Now if we look at these terms, these residual terms, we can easily observe that a number between 1 and half to the 4th power over 24 will be approximately 0. Okay, so all of these terms will be approximately 0, because if I put 1, then it will be 1 over 24, and if I put half, then it will be even more less than that. So we can ignore these all terms because these are approximately 0. Okay, they are almost 0. And now from here, there is a very simple thing happens, that L equals to 1 minus L square upon 2. We can, after multiplying by 2, I can say that 2L equals to 2 minus L square, and L square plus 2L minus 2 is 0. After using quadratic formula, I can see that L equals to minus 2 plus minus root 4 plus 8 over 2. It will be minus 2 plus minus, it will be 12 over 2. What we can write 12 as 4 times 3, and we can again write this as minus 2 plus minus 2 root 3 upon 2, and L will be minus 1 plus minus root 3. we can ignore this minus 1 because in that case L will be negative, but after this we can observe that L will lie in this range. So L is approximately this. Okay, L is approximately this. So what is root 3? If you know, then root 3 is itself approximately 1.732. So after putting here, I can see that L is approximately 0.732. This constant is famous by the name of Dottie number. Okay, so there was a professor, her name was Dottie, and he accidentally found this constant after repeatedly pressing the cos in her calculator. So that problem was originated from here. So that constant name is Dottie number, and it was accidentally found when she was randomly clicking cosine function in her calculator. She observed that taking cos many times to any x, there will be a number, at last it would finish. So what if we take sine instead of cos? After taking sine and following the same steps, we will end up here, and it is very simple. It is very simple that we can say that L will be 0. So this limit will be 0.